Okay, we're going to be looking at solving trigonometric equations. A couple of brief things to remember that unlike solving for right triangles, instead of solving for degrees, we'll be solving in radians. And instead of looking for decimal approximations, we want exact answers. Let's remember some of the tools we have available for solving equations before we look at the trigonometric ones. So for example, if I came across an equation such as this, what do I know I have to do? Well, because I see more than one variable, right? I see the x with the 5x squared, but then I see it in another location with the 8x. Instead of isolating the variable and solving, instead I'm like, nah, better set it equal to 0 and factor. So I better set it equal to 0. Subtract 8x from each side. So I still have my 5x squared. Then I'll place my negative 8x. I still have my minus 4, but now it's set equal to 0. And now I can factor, or if I preferred, I could solve by completing the square, or if I preferred, I could use the quadratic formula. I always find factoring to be the most convenient. Of course, how do I know for certain it's actually factored correctly? Check with FOIL. All right. First term in each, 5x times x is 5x squared. Outer, they'll give me a negative 10x. Inner, positive 2x. Last, negative 4. And sure enough, negative 10x plus 2x becomes negative 8x. So sure enough, I've got a perfect match there. Now, of course, I need to take each factor and set each factor equal to 0. Solve each of the resulting equations. And I've got two answers. X could be negative 2/5. X could be positive 2. Let's see how we would apply this type of work with trigonometric equations. Right, we've got a lot more tools available. Right, we didn't use the quadratic formula, we didn't factor by grouping, but we got the general idea. Okay, now we're going to restrict it to one trip around the unit circle. Notice that it just says less than 2 pi and not less than or equal to 2 pi, because 2 pi is the exact same location as 0 on the unit circle. So for the solutions, we start at 0, we go counterclockwise around the circle, and we stop just before we reach 2 pi. And it's customary that instead of using x for the variable as we would in algebra, with trigonometry, we often use theta for the variable. So, hey, I only see the variable in one location. I can just go through my order of operations. I can undo PEMDAS, purple elephants merrily dance after sunset. Right? I can undo any adding or subtracting. So I can add 1 to each side of the equation. Now I can undo any multiplying or dividing. Opposite of multiplying sine of theta by 2 would be dividing by 2. So I divide each side by 2. I now know sine of theta has to equal 1/2. Okay, so where am I? Don't grab a calculator. The calculator is only going to give you one answer. Right? Arc sine would be constricted between negative pi over 2 and pi over 2. We don't want to use any negative angles here. And we certainly don't want to stop at pi over 2. So as I go around the unit circle, it looks like sine of theta is positive 1/2 when I'm at pi over 6. It looks like sine of theta is positive 1/2 when I'm at 5 pi over 6. So there are two valid solutions to that equation. Again, this is why we only go around the unit circle one time. Otherwise, there'd be an infinite number of solutions. Again, I only see theta in one location, so I can just solve by undoing the order of operations. Undo any adding or subtracting, so I can add 3 to both sides of the equation. Opposite of multiplying by 4 is dividing by 4. Hey, there's even an exponent to undo. Opposite of square to square root. Remembering to take the plus or minus. In the numerator, square root of 3 I'm stuck with. In the denominator, square root of 4, of course, is just plain old 2. Well, where am I when cosine of theta is either positive or negative? Root 3 over 2. Looks like the first occurrence is at pi over 6. Next time that it's either positive or negative root 3 over 2, 5 pi over 6. The next time it's either positive or negative root 3 over 2, 7 pi over 6. And there's even a fourth occurrence where cosine is either positive or negative root 3 over 2, and that's 11 pi over 6. Right, there's two places where cosine is positive root 3 over 2. That was pi over 6 and 11 pi over 6. Two locations where cosine of theta was equal to negative root 3 over 2, 5 pi over 6, and 7 pi over 6. There are 4 valid solutions to that equation. Okay, I see theta in more than one location. Cosine squared theta and cosine theta are not like terms, so I cannot combine them. Since I cannot combine them, I know I'm going to have to do something besides undoing the order of operations. Again, I prefer to factor if possible. Looks to me like it would be 2 cosine theta plus 1 times cosine theta plus 1. How do I know if I factored it correctly? I gotta check with FOIL. That's truly the only way I'm going to know if I've factored correctly. So let's see, 2 cosine theta times cosine theta, that's 2 cosine squared theta. 2 cosine theta times 1, 2 cosine theta. 1 times cosine theta, cosine theta. 1 times 1 is 1. So sure enough, I've got the 2 cosine squared theta. And now O and I combine to become 3 cosine theta. And then there's the plus 1. So sure enough, it matches. I think factoring is much easier than completing the square or using the quadratic formula. If I'm factored, I set each factor equal to 0. Solve each equation, or at least solve it as far as I can. It looks like I'll be happy anytime cosine of theta has a value of negative 1/2, and anytime cosine of theta equals negative 1. So the first point I come across, 2 pi over 3. Cosine has a value of negative 1/2. Pi, cosine has a value of negative 1. 4 pi over 3 is where cosine has a value of negative 1/2. 3 valid solutions. see theta in several locations. I would try to combine like terms, but I don't see any like terms I'm allowed to combine. Secant theta tangent theta does not match secant theta. Secant theta does not match 2 tangent theta. Right? Those are all different terms. I cannot combine them. So again, factoring is what I usually find to be the most efficient method. There are 4 terms, so I'm guessing that factor by grouping would be my first choice. If factor by grouping does not work, then I might have to consider if it's one of the 1, 3, 3, 1 situations from Pascal's triangle, or possibly have to resort to synthetic division. So hopefully factor by grouping will work. So from the first 2 terms, secant theta is my common factor. If I factor secant theta out of the first 2 terms, it'll leave me tangent theta in the first term, and it'll leave me just 1 from the second term, because that will give me secant theta times tangent theta, and then when I do secant theta times 1, it gets me the secant theta. Of course, I better have the subtraction symbol in there because it was subtraction. Now, from the 3rd and 4th terms, if I factor out the 2, the signs are not going to match. So I need to actually factor out a -2. Of course, factoring a -2 from the tangent theta will leave me tangent theta. And then factoring a -2 from the +2 leaves me a -1. Because -2 times -1 makes +2. Of course, we're really not factored at the moment, because factoring implies that we are multiplying. I see subtraction in the middle of this. So I've got to rewrite it with multiplication in the middle, not subtraction in the middle. So we're using the distributive property. It looks like the tangent theta minus 1 is getting multiplied by both secant theta and -2. So secant theta and -2 is one of my factors. Then obviously tangent theta minus 1 is the other factor. How do I know if I'm factored correctly? Again, the moment of truth. First, outer, inner, last. Sure enough, it matches. It is factored correctly. So now that I know that it is factored correctly, I can set each factor equal to 0. Solve the equation. So either secant of theta has to be 2. Of course, secant of theta is not going to be on my unit circle cheat sheet. So I know that that really means cosine of theta is 1/2. Or tangent of theta equals 1. It gets a little bit tricky because on my unit circle, I just have sine and cosine labeled. So let's run around the circle and see where we can come by. Start at 0, no. Go to pi over 6, no. Go to pi over 4, aha. I've got a winner at pi over 4. Root 2 over 2 divided by root 2 over 2 is 1. Remember, tangent of theta is sine of theta divided by cosine theta. So pi over 4 works for tangent being 1. Of course, my next stop, pi over 3. Because the value of cosine at pi over 3 is 1/2. Pi over 2, nah. 2 pi over 3, no. Cosine is -1/2 there. I don't want -1/2. 3 pi over 4, no. Tangent would have a value of -1 at that location. 5 pi over 6, no. Pi, no. 7 pi over 6, no. 5 pi over 4, aha. Sine of theta divided by cosine of theta would have a value of 1 there. Negative root 2 over 2 divided by negative root 2 over 2 is positive 1, so that works for tangent. 4 pi over 3, nah. 3 pi over 2, no. 5 pi over 3, aha. Cosine has a value of positive 1/2 when theta is 5 pi over 3. 7 pi over 4, nope. 11 pi over 6, nope. 2 pi would get us back to the beginning, and we wouldn't want to include 2 pi anyway. So there are 4 valid solutions to this equation. Theta could be pi over 4, pi over 3, 5 pi over 4, or 5 pi over 3. And again, today, instead of on IXL, the assignment is actually a worksheet.